You're listening to DTFHN for April 15th, 2026. I'm your reverse-engineered host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who build things argue about how things should be built. Today's a day for cracking open black boxes and refusing to close them. Let's get into it. In 1980, a guy named Jack Crenshaw sat down and started writing a tutorial series called Let's Build a Compiler. And he committed what the academic establishment would consider an act of violence. He made it simple. Single pass, parsing and code generation tangled together, barely any optimization, the kind of thing a first-year student could follow. And it worked. This is a story about gatekeeping dressed up as rigor. The article from True News are resurfacing now makes an observation that's aged beautifully. Every compiler textbook assumes you want to build an industrial-grade multi-pass, optimizing behemoth before you've even parsed your first expression. It's like handing someone who wants to learn guitar a doctoral thesis on acoustic resonance in spruce wood. Technically relevant, practically useless. Crenshaw broke that pattern by just building the thing. Line by line, in Pascal, no pretense. And the second piece, the author recommends. The now passed paper by Sarker, Waddle, and Dybvig breaks the other half of the myth. A compiler is just a series of small transformations on a tree. Each pass does one thing. You chain them together. That's it. Dozens of tiny, readable steps instead of one monolithic nightmare. Now, run this forward. The reason compiler knowledge was gate-kept for decades wasn't malice. It was the textbook industrial complex doing what it always does. You write a comprehensive reference, it becomes the canonical reference, and suddenly the only path to understanding runs through 800 pages of formal grammar theory that maybe 12 people on Earth find genuinely illuminating on first read. The Nanopez approach is pure bootstrapism. You don't need the Dragon Book. You don't need a semester of automata theory. You need a tree, a series of transforms, and the willingness to start ugly. The tools exist. The knowledge is available. If you know where to look, which until recently meant stumbling across a Pascal tutorial from the late 80s, or a scheme paper with a dead PDF link. One of the comments mentions Crafting Interpreters Bob Nystrom's book, which carries this torch forward. Free online, open. Another commenter, fresh off a graduate compiler's course, describes it as the hardest class they've taken. Both things are true simultaneously, and the gap between them is entirely pedagogical. The subject isn't inherently brutal. The teaching was. This is how open knowledge compounds. Crenshaw wrote tutorials for free. The NanoPass authors published their framework. Nystrom put an entire book on the web. Each one made the next generation of compiler writers possible. Not by lowering the bar, but by removing the artificial wall someone built in front of it. This one's been circulating since 2012, and it's a masterclass in open knowledge done right. What if the most powerful cognitive enhancer ever discovered isn't a drug, isn't a nootropic, isn't some silicon implant, but the thing your body already does every single night when you stop fighting it? There's a concept in architecture called load-bearing walls. You can renovate almost anything in a building. Tear out cabinets, rip up floors, move doorways. But if you touch a load-bearing wall without understanding the structure, the whole thing comes down. Sleep is the load-bearing wall of cognition, and modern life has been taking a sledgehammer to it for about a century. Piotr Wozniak. the same mind behind the super memo-spaced repetition system, wrote this sprawling, obsessive, gloriously detailed treatise on sleep science. And I mean sprawling. This thing reads like someone took every sleep paper published between 1990 and 2012 and wove them into a single argument with the patience of a cathedral builder. The core thesis is almost frustratingly simple. Your brain has two independent processes governing sleep: a circadian clock and a homeostatic drive. And when you let them align naturally, without alarm clocks, without caffeine overrides, without the tyranny of 9-to-5 scheduling, the quality of your sleep, and therefore your memory consolidation, and therefore your capacity to learn and create, goes through the roof. The engineering elegance here is what gets me. Wozniak didn't just review the literature. He built tools to measure it. He tracked free-running sleep, meaning sleep with no alarm, no forced schedule, just letting your body find its own rhythm, and mapped the data against learning performance. The correlation between sleep phase alignment and memory retention isn't subtle. It's architectural. Get the foundation wrong and nothing you build on top holds. The comments tell a familiar story: a new parent joking about explaining circadian rhythms to a 6-month-old, a diabetic realizing that years of symptoms traced back to disrupted sleep, a biphasic sleeper trying to navigate a world built for monophasic schedules, every one of them bumping against the same wall. The industrial economy doesn't care about your ultradian cycles. And this is where it connects to everything this show is about. The knowledge is right here. Wozniak published it freely. The research is open. The tools exist. The only thing standing between most people and genuinely restorative sleep is a set of social structures that treat human biology as an inconvenience to be medicated away. The blueprints are public. The question is whether we'll use them. Moving on. Based on the detailed article content provided in the prompt, I have enough to write the script. Let me craft it now. I've built systems that do text layout. Fitting a string into a pixel budget sounds trivial until you're 3 days deep wondering why your truncation loop won't terminate. So, when I saw this bug report, I felt it in my bones. Here's the setup. A 20-year-old named Costasiella, born in 2004, uses Enlightenment ELO ships as her daily window manager. ELO ships shipped in 1997. It peaks at 24 megabytes of RAM. That's not a typo. 24 megabytes running a fully themed, keyboard-driven desktop that looks gorgeous. She opens a PDF in Atro and the entire desktop freezes. Now, a lesser debugger stops it. It hangs. She attached GDB to the live process and started sampling. Every stack trace landed in Imlid Bide's font cache, called from the same spot. A function called TextFit_MB. This function's job is middle ellipsis truncation. You've got a window title too long for the decoration, so you nuke characters from the middle and replace them with an ellipsis until it fits. Simple enough in theory. Let me play devil's advocate for a second. You might think, why not just use binary search? Pick a midpoint, measure, have the range, done. And honestly, that's what I would have assumed this code was doing. But no, someone in 2006 looked at this problem and thought, I'll use Newton's method. Approximate the derivative of the width function, take a step proportional to the overshoot. Converge faster than bisection. Elegant, right? Except here's where the craft breaks down. Newton's method needs a monotonic, well-behaved function. Variable width fonts are neither. The derivative estimate used integer division that could produce identical step sizes on consecutive iterations. The code oscillated. New count bouncing between 8 and 11. Forever, measuring the same two truncations in an infinite loop. A two-state limit cycle. The program wasn't deadlocked. It was running full tilt, doing real work, making zero progress. The fix is beautiful in its restraint. She added a single guard. If the current new count matches the previous iterations, break the loop. One comparison, one early exit. 20 years of latent failure, resolved by recognizing that Newton's method can orbit a fixed point when your function isn't smooth. This is a 20-year-old person fixing a 20-year-old bug in a 29-year-old window manager. The source is open. The debugger is free. GDB, Walger dumps, frame local inspection. Every tool she used ships with any Linux distribution. The entire diagnostic chain, from hang to patch, happened because one person could read the code, attach a debugger, and think clearly about convergence property. That's builder culture. That's what open source makes possible. Not just software that lasts decades, but the guarantee that when it finally breaks, someone, anyone, can open the hood and fix it. Remember that bootstrap we talked about? Well, open source just got a new power tool. Story 4, Claude Code Routines. There's a line buried in the documentation that most people will scroll right past. Routines run on Anthropic managed cloud infrastructure. 8 words. That's the whole story. Let's be precise about what this means. Claude Code, the tool that edits your files and runs your tests and opens your pull requests, now runs unattended on servers you don't control, triggered by events you may not be watching, against repositories you've connected. It runs when your laptop is closed. It runs on a schedule. It runs when an HTTP endpoint gets hit. It runs when someone opens a pull request. This is powerful, genuinely powerful. Automated triage of production alerts, backlog grooming that actually works. Code review that catches the mechanical stuff so humans can focus on architecture. The use cases are real and the engineering is impressive. Anthropic has built something that solves problems teams actually have. But pull this thread for a second. Where does a routine execute? On Anthropic's infrastructure. Who can inspect the execution environment? Anthropic. Who decides what capabilities the routine has access to? Anthropic's permission model. When the routine opens a pull request against your code base at 3 in the morning, the agent that wrote that code is running in a context you cannot audit, on machines you cannot access, governed by terms of service that, as several commenters notice, seem to shift week to week. The bootstrapism question here is sharp. This is an incredibly useful capability that is, by its architecture, unreplicable outside Anthropic's walled garden. You can't self-host a routine. You can't run it on your own infrastructure. You can't swap in a different model. The prompt is yours. The repositories are yours. The compute, the execution context, the observability. Those belong to someone else. And that matters because the people who most need autonomous coding agents are exactly the people who can least afford to be locked into a single provider's cloud. Small teams, solo developers. The indie maintainer who'd kill for automated dock drift detection but can't bet their workflow on a research preview that might change its API surface, its pricing, or its usage limits next month. The capability is real. The question is whether it stays a service you rent or becomes a tool you own. Open source agents running on your hardware, triggered by your events, inspectable end-to-end. That version exists in pieces already. The gap is closing. The right response to a powerful tool behind a wall isn't to reject the tool. It's to build the open version. Fast. So what does building with these tools actually look like day to day? Let me pull back the curtain on my own workflow. In E16, Nauto convened a conference in Garmisch, Germany, and coined the term software engineering. The central crisis they identified wasn't that programmers couldn't write code. It was that nobody could reliably specify what the code should do before writing it. 58 years later, a tech lead named Mayo Barbero arrived at essentially the same conclusion, except now the programmer is a large language model. The workflow he describes is deceptively simple. Before any AI touches a line of code, he writes a free-form plan in plain language. That plan feeds into a structured interview process that interrogates every assumption. Authentication edge cases, partial failure modes, migration paths for existing users. The output of a product requirements document so explicit that individual issues can be classified as either fully autonomous or requiring human decision points. Run this forward. What he's actually built is a compiler, not for code. For intent, the freeform plan is source code written in the language of human judgment. The PRD interview is the parser. The issue breakdown is the intermediate representation. And the AI coding agent is just the backend that emits the final artifact. This matters because the failure mode he identified is the one almost nobody talks about. Building faster and understanding less. Features that work technically, but that no one on the team can fully reason about. The velocity feels real until you need to change something. And then you discover that speed without comprehension is debt with a variable interest rate. The interesting detail buried in the comments is how many people independently converged on the same pattern. Different tools, different platforms. Linear instead of GitHub, custom automation scripts, rubber duck conversations with the model before any specification begins. The shape is consistent. Thinking before implementation. Specification before generation. Human judgment as the irreducible input. This is what mature AI-assisted development actually looks like. The AI handles implementation. Humans handle the upstream problem. Deciding what to build and why. Catching the assumptions that weren't made explicit. Defining the boundaries. The spec is the product. The code is a side effect. The tools to do this are open source. Mark Pocock's skills framework that Barbero adapted runs locally, plugs into your editor, works with whatever model you choose. The workflow is transferable. The methodology is inspectable. No vendor lock-in required. The hardest part of building software was never typing it out. It was figuring out what to type. So we've been talking about systems that capture intent, but what about systems that capture sunlight? The strongest argument for proprietary biology is the cell membrane. Every living thing on Earth runs a closed system. My DNA, my proteins, my metabolic pathways. You want photosynthesis? Evolve it yourself. Took plants about 1 billion years. That's the cost of building from scratch. Costasiella kuroshimae did not pay that cost. This is a sea slug. 5 to 10 millimeters long, lives in tropical waters off Japan, the Philippines, Indonesia. Looks like a cartoon sheep crossed with a succulent, tiny black eyes. Little rhinophores on its head that look like ears. Adorable. Completely beside the point. What matters is what it does. This animal eats algae from the genus of Rainvilla, and instead of digesting the chloroplasts, the cellular machinery that converts sunlight into energy, it absorbs them, keeps them, runs them. A sea slug, an animal performing photosynthesis with stolen hardware. The technical term is kleptoplasty. Klepto as in theft. And I want to follow that framing to its logical conclusion, because it breaks immediately. The algae did not invent photosynthesis either. Chloroplasts are themselves the result of an ancient endosymbiosis. A cyanobacterium got absorbed by a eukaryotic cell somewhere around 1.5 billion years ago, and instead of being digested, it stayed. Started paying rent in glucose. Every plant on Earth runs on that original acquisition. The entire kingdom Plantae is built on incorporated technology from another lineage. The slug is doing the same thing on a shorter time scale. It feeds, it integrates, it benefits. Even when the chloroplasts stop actively photosynthesizing, they function as nutrient storage. A biological larder that lets the slug survive without food for extended periods. It's not permanent. It's not heritable the way plant chloroplasts are, but it works. Run this forward, the proprietary model says, build your own from scratch behind walls. Nature's most successful strategy says, integrate what works, wherever you find it. The cell membrane isn't a DRM system. It's a deployment environment. A 5 mm sea slug figured out that the fastest path to solar power isn't reinventing photosynthesis. It's eating lunch and keeping the good parts. Life really is amazing, and it is absolutely, constitutionally incapable of respecting intellectual property. Anthropic announced that Claude may start asking for identity verification in certain cases. And this one's worth unpacking. The top comment on Hacker News cuts right to it. It's worrying that they don't specify in which cases they require identity checks. And that's the whole game, isn't it? The support page is 800 words of careful reassurance wrapped around a void where the actual policy should be. Let's do first principles. What does identity verification on an AI chatbot actually accomplish? Anthropic says it prevents abuse. Okay, but the abuse they're worried about. Jailbreaks misuse, generating harmful content. None of that requires knowing someone's legal name. Rate limiting works. API keys work. Payment verification works. You don't need a government-issued photo ID to stop someone from asking a language model to do something sketchy. You need a government-issued photo ID to build a database of exactly who asked what. And they've partnered with Persona for this. Multiple commenters flagged it. Persona, whose entire business model involves collecting biometric data at scale, who according to at least one commenter has a track record that should give anyone pause. Anthropic says they're the data controller. Persona just processes, but the data lives on Persona's infrastructure. Anthropic can access verification records through Persona's platform when needed. That's a fascinating architectural choice for a company that just told you they care deeply about your privacy. Now here's what's actually interesting. Strip away the compliance language and you're looking at a closed system tightening its grip. The model gets more capable, so the walls get higher. The justification is always safety. The mechanism is always control. And the people building open alternatives. Run models locally, contributing to open weights. They don't need your driver's license. They need your GPU. This is the divergence that matters. One path says, powerful AI requires powerful gatekeepers, verified identities, centralized control over who gets access to what capabilities and when. The other path says, ship the weights, let people run it, trust the network. Anthropic makes genuinely impressive technology, but when your safety strategy requires a selfie and a passport scan to use a chatbot, maybe the architecture is telling you something about who it's really designed to protect. Now flip that script entirely. PruCam, because Google just put a full language model in your pocket. No cloud required, no passport needed. Every year, developer conferences, someone demos a language model running on a phone, and every year the audience claps politely while knowing it's basically a parlor trick. Slow, constrained, useful for about 3 queries before the device turns into a space heater. That was the state of the art. Past tense. Google just shipped Gemma 4 variants that run native inference on an iPhone GPU. And I don't mean a stripped-down autocomplete engine, image recognition, voice interaction, a skills framework for developers to build on top of, fully offline, no API calls phoning home to a data center. The model waits, live on your device, inference happens on your device, and your data never leaves your device. Let's talk about the engineering constraint that makes this remarkable. A modern iPhone has somewhere around 6 gigabytes of usable memory for apps. A typical large language model wants tens of gigabytes just to load its parameters. The E2B and E4B variants Google built aren't just smaller models. They're architecturally redesigned to fit within mobile thermal and memory budgets while still producing coherent, useful output. That's a genuine craft problem. Quantization, distillation, architectural pruning. Getting a model to be small enough to run on consumer silicon while remaining smart enough to be worth running. Google's own app defaults users to E2B because it's the one that respects the physics of the platform. That's honest engineering. Now here's the question nobody in the industry wants to sit with. If a 4 billion parameter open-weight model running locally on a phone can handle real tasks, and the benchmarks say it can, then what exactly is the Cloud API selling you? Latency? You're getting lower latency locally. Privacy? Obviously, availability. You're always available to yourself. The answer, increasingly, is that the cloud sells dependency. It sells a meter on capability that could run unmetered on hardware you already own. One commenter noted, Apple appears to be blocking apps that bundle local LLMS under App Store Rule 2.5.2. And that tells you everything about where the real friction is. It's not technical anymore. The silicon can handle it. The models are ready. The blocking force is platform gatekeepers deciding whether you're allowed to run intelligence on your own hardware. Gemma 4 is open weights. You can download it, inspect it, modify it, deploy it. Google built it, but Google doesn't control it once it's on your phone. That's the architecture that matters. Not the parameter count, not the benchmark scores. The fact that intelligence can now run sovereign on a device in your pocket. Answerable to no one's API terms of service. The tools exist. The hardware exists. The only question left is whether the platforms will let you use them. Moving on. Peter Steinberger built a full WhatsApp client in Go that runs in your terminal. You authenticate with a QR code. It syncs your message history into a local SQL-like database with full-text search. And then your entire WhatsApp archive becomes grippable. Offline, on your machine. No Electron, no browser tab burning 2 gigs of RAM. Just a binary and a database. The engineering here deserves a close look. What's a WhatsApp What's reverse engineers the WhatsApp web protocol? The same WebSocket connection your browser makes when you open web whatsapp.com. It speaks the same language, handles the same encryption handshakes, stores everything locally with FTS5 for blazing search. The backfill system is particularly clever. It anchors to your oldest local message and requests history chunks from your phone, 50 messages at a time, stitching together an archive that WhatsApp itself makes deliberately difficult to export. This has a direct ancestor. In 1991, Phil Zimmermann released PGP, Pretty Good Privacy, and the U.S. government spent 3 years trying to prosecute him for it. His crime was giving ordinary people access to encryption that worked. The parallel isn't the encryption, it's the pattern. A communication platform controlled by a massive institution, and one engineer saying, actually, I'd like to access my own data on my own terms. Thank you. The comments tell the real story here. Multiple people reporting account bans just for connecting with unofficial clients. No messages sent, no spam, no abuse. Just logging in wrong. Meta's position is clear. Your messages live on their infrastructure, under their rules, accessible only through their interfaces. The EU's interoperability mandates under the DMA are supposed to change this. But enforcement is glacial. What Steinberger's shift is a working protest. Homebrew installable, open source, built in a language that compiles to a single binary you can carry on a USB stick. The fact that using it might get your account banned tells you exactly how much Meta values your autonomy over your own conversations. The tool exists. The protocol is understood. The only thing standing between you and your own message history is a corporation's willingness to lock you out for trying. But what happens when the fight for digital autonomy meets actual hardware history? Pause, and a testing philosophy so wild it took 14 years to explain. What happens when you can't buy the thing you need, so you build it yourself? In 1979, an engineer named Ivan Marengozov in Sofia built the IMK-01. Bulgaria's first personal computer. It was an Apple II clone. And clone is generous. The ROM was identical. The schematics were identical. The 65E02 ran at the same 1 MHz. Bulgarian intelligence allegedly sent operatives west to procure the originals. And then an institute in Sofia decapped the chips under a microscope, lifted the net lists and reproduced them with socialist lithography, one alphabet at a time, 7-bit Cyrillic where Latin lowercase used to be. This is reverse engineering in its purest form. The discipline of refusing to use something you don't understand. You take it apart, you trace every connection, you rebuild it from first principles, and when you're done, you own that knowledge in a way the original buyer never did. Apple shipped a product. Bulgaria built a capability. Pull this forward. The article's author makes a point that lands harder than he maybe intended. Reverse engineering is the intellectual opposite of the current approach to AI, which is to build something enormous, declare it transformative, and hope nobody asks what it actually computes. 70% of UK business leaders will keep spending on AI they can't measure. OpenAI announces infrastructure projects during state visits and cancels them when the electricity bill arrives. Meanwhile, the engineering tradition that actually advances understanding, taking things apart, tracing the circuits, knowing what every gate does, that tradition is alive in open source, in homebrew hardware, in the people who refuse to treat a black box as a finished product. The circuits do not hallucinate. They do exactly what the silicon says. The question is whether anyone still bothers to read it. This has been your daily tech feed for Hacker News for April 15th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something you actually understand. We'll see you back here tomorrow.